So today we're going to continue with exponential functions. So number one, y equals 4 times 0.6 raised to the x. So to raise anything to a power, you hit this arrow or caret button, and x next to alpha, move over to the right, and -6. And a reminder, if you press enter and something changes to multiplication, you know that you did negative instead of minus. So graph. If your graph does not look like this, one, either reset your calculator by going to second, the plus sign, which is memory, 712, or zoom standard. So notice this one, it goes down, but as we talked about yesterday, it's going to hit a plateau, which is called asymptote. Its asymptote is where it never crosses, and then it goes up on the negative side infinitely. So if we look at our table, you will find as our x increases that it's getting close to -6. Eventually, because of rounding, it will say -6, but it never crosses -6. Now on the x side, I can continue to go both up and down, and I will always have an x. So your graph, your sketch, so it's going to plateau here at the -6, and it's going to continue to rise. So my domain is going to be all real numbers. And there is a symbol for that. It's a double-legged R. And then don't forget, on Get More Math, you go below your symbols and your numbers, and you'll have the button to push all real numbers. Don't type it out. Your range, since it never equals 6, but it gets close, it's going to be y is greater than the -6. So y is greater than -6, and it's going to continue to go up. So again, if you look at the table, notice that -18, we're already at 29,000. So it goes up really fast. So it'll take a long time to finally go to the left, but it will continue to go up. Number 2. And I have already graphed, I already put all these in y equals, so I'm just going to unhighlight it. And this is my second equation. And this time we only have to put the range. So the range, this time it's going down. So notice that the 4 on number 1 is positive and it's going up. The number in front, which is, if there's not a number, it's -1, it's going down. And so the function is negative, so it's going down. And it is going down from, you can guess it, -3. So look at our table. Good news is you don't have to memorize that. You can look at it. So we're going back to 0. And so it's getting close to -3, but it's never crossing it. It's never going to -2 point something. So it's going to be y is less than -3. And then number 3, again, it's negative, and it's at -3. So because it's negative, it's going to go down, and my asymptote is going to be at -3. And if you don't remember, that's fine. Just graph it and look at it. Or if you just want to make sure. So there's the plateau, so it's going to stay flat at -3. And then it's going to go down. So y is less than -3. Okay, back side. I did a few of these examples. So they gave you the graph. And so, again, we have a flat and it's plateauing. So this one is a negative. And the domain is going to be the same for all of them. They're going to be all real numbers. So your double-legged R. My range is going down, so it's going to be y is less than. So reminder, if you have trouble with the less than, and greater than symbols, the less than is a L that is squished. And less than, -1, -2. And I'm going to skip this one real quick. I'm going to go down to the other graph. Again, our domain is going to be all real. And this time it is going up. So y is greater than 1, 2, 3. Again, if there's no units on the graph, you're assuming that it's 1. Be careful on the linear domain and range. They change the units quite a bit. And number 4, we're going to graph it. And notice it is positive, and we're not adding anything. So hopefully you can guess at this point what your range is going to be. But if not, let's graph it. And graph. And so it is positive, so it's going up. And the asymptote is at 0. So y is greater than 0. And that is it for today. Thank you.